Now, suppose you want to find the maximum rate of change of the function at the given point 1 and 0. Very good. So remember, we talked about the gradient of the function, I'm right. The only thing we need to do is to find the gradient of the function and then find the magnitude of the gradient of our function. So let us find the gradient of the function. This is defined as, well, here we need to take the partial derivative of f with respect to x, and then take the partial derivative of f with respect to y, and then evaluate that at 1 and 0. So the gradient of the function is equal to, with respect to x, you have e to the power negative y, and since this guy doesn't have any x in it, it's going to be 0, comma, with respect to y, it is going to be negative x e to the power negative y plus 3. So remember that when you have e to power x, the derivative is e to the x. If you have e to power minus x, you apply the chain rule, we get negative e to power minus x. This is the situation that we have with e to power negative y. So in general, if you have e to power t, to avoid any confusion, it's going to be e to the t. And if you have e to power negative t, it's going to be negative e to power negative t. So now let us plug in 1 and 0. The gradient of the function at 1 and 0 is equal to e to the power. Let's just write it with positive exponent so you see what's happening here, comma, and here we have negative 1 divided by e to the power 0 plus 3. So the gradient of the function at point 1 and 0 becomes 1 over 1, which is 1, and then you have negative 1 plus 3, which is 2. Now the magnitude of the gradient at 1 and 0 is the maximum rate of change of the function, which is square root of 1 squared plus 2 squared, or square root of 1 plus 4, or square root of 5. This is the maximum rate of change of the function at the point 1 and 0.